Hello, my name is Sheldon Carvalho, and my team and I, as Lean Six Sigma practitioners, were tasked with the responsibility of helping a struggling company, the Lean Sandwich Shop. I'm excited to present to you, through the lens of the Lean Six Sigma methodology and tools, the actions that we took to identify the root cause problems, as well as provide solutions to improve the quality and production processes that ultimately helped to eliminate waste and to provide savings for the Lean Sandwich Shop. So the agenda for the presentation is as follows. I will be discussing the Lean Sandwich Shop's challenges, provide an analysis overview, provide innovative solutions to correct the root cause problems, provide an improvement mechanism offering the work cell that we created, and I will wrap it up with a conclusion. The Lean Sandwich Shop Challenge. Well, the Lean Sandwich Shop is a new venture and actually holds a strategic value due to the downtown location in a large city at a busy commerce district. However, the Lean Sandwich Shop has been struggling since their opening launch. And why have they been struggling? Well, they currently have quality and production issues that results in orders falling behind, and 10% of their sandwiches do not meet customer standards and require a new sandwich. That is a lot of scrapped material and a lot of wasted time and product and money. 10% of the annual scrap sandwiches, which equates to approximately 21,840 sandwiches, equates to an annual failure cost of a little over $120,000. If the Lean Sandwich Shop does not make changes to turn around the business, it will hurt their reputation and impact opportunities for additional sites. My team and I decided to begin with the end in mind. Thus, our goal statement is as follows. First, improve. Improve sandwich quality to reduce the current scrap rate of 10% down to 2% in 3 months, resulting in a $96,096 annualized cost savings. Second, decrease. Decrease the number of defects, the DPMO, from 100,000, which is an average of 60 defects per day, to 20,000, down to an average of 12 defects per day. And lastly, improve. Improve workflow processes to reduce annual labor costs from $655,200 to $436,800 in the next 3 months. The result will be a labor cost savings of $218,400. The method we used to identify the root cause problems and provide solutions to the Lean Sandwich Shop, we're using the following analysis tools. The Pareto analysis, which identified the root cause problem, the TPH, the DPMO, the attack time, work balance table, the work combination chart, and the validation model, thus showing the productivity improvement and scrap rate reduction improvement. Through the use of customer surveys, we were able to extract the data and apply it to the Pareto analysis chart. The Pareto analysis chart helped us to identify that the top issue that customers had with the Lean Sandwich Shop were cold sandwiches, approximately 37%. Furthermore, the Pareto analysis helps us to identify the area that we need to focus first in process improvement, which is improve our sandwich quality. So for us to provide innovative solutions, we wanted to take a look at the current process. So at the Lean Sandwich Shop, the current process consists of a 10-hour workday, 7 days a week, and 364 days per year. The Lean Sandwich Shop averages 600 orders per day, and the current process workflows is as follows. As you can see, there are 7 tasks, and each task has a designated activity that they are to perform. And below each task, you can see how long it takes per task for the workflow to go through. So the aggregate of all of these tasks equates to 600 seconds. Continuing with the current process. Currently, they have 12 employees working per day. They have a TPH of 5, a takt time of 60 with 12 employees, and each task has designated employees, 3 employees for task 1, 1 employee for task 2 and 3, 2 employees for task 4, 3 employees for task 5, 1 employee for tasks 6 and 7. Next, we use the current work balance tool to help us identify if there are any issues with the current process. As you can see on the graph, we use the yellow line to indicate the 60-second takt time. And the takt time is the rate at which you need to complete a product to meet your customer needs. And as you can see, the task number 3, add protein to the sandwich, is currently over the takt time, and that's an issue. On the flip side, in task number 2, receive order and select bread, it's not really being utilized properly, as well as a little bit of the record and deliver order and deliver the sandwich to the customer. So those are some of the areas that we wanted to consider. Can we update or change by adjusting or combining tasks to help improve the process cycle time and ultimately the production process? As stated before in the previous slide, the balance table identifies the bottleneck of the process cycle, which is task number 3, add protein to the sandwich. The current workflow has 1 employee assigned to task 3, and that's something that we are going to take a look into. And lastly, process cycle time for task number 3 is 90 seconds, which is above the takt time of 60 seconds, and that will not help us meet the needs for completing the product for the customer demand. In addition to the work balance table, we utilized the work combination chart tool. In doing so, we were able to identify that for task number 5, that's something that we should also consider, because the toaster time takes up 145 seconds while the employees are only working a total of 20 seconds, due to the fact that task number 5 takes a total of 165 seconds. There are 3 employees and 3 toasters, so right now the employees are currently waiting around while the sandwich is being toasted. That is a lot of waste that is occurring. And we need to note that cold sandwiches was the top reasons for customer dissatisfaction with the lean sandwich shop. Thus, task number 5 needs to be restructured to speed up time to get sandwiches to customers right out of the toaster so that it is a nice, fresh, warm sandwich. The result, the innovative solution that we came up with is that we updated the process. As you can see, we are still considering the lean sandwich shop process consisting of a 10-hour workday, 7 days a week, and 364 days per year. The lean sandwich shop will still average 600 orders per day. However, we took the process workflow from 7 tasks down to 4. We were able to combine a few of the tasks into one. Task number 1, record and deliver an order, still there. Task number 2, we combined the receive order and select bread and add protein to the sandwich. Task number 3, we kept it the same, add vegetables and toppings, but task 4, we're able to combine 3 tasks into one. Place the sandwich in the toaster. While that sandwich is being toasted, the worker can then wrap the sandwich and also help with delivering the sandwich to the customer. And the toaster consists of 3 machines. Thus, with this innovative solution and updated process to the production workflow, the employees reduced from 12 to 8. The TPH increased from 5 to 7.5. The takt time of 60 is still there with 8 employees. As you can see, with the 4 tasks, we have 2 employees per task. Thus, that really helped reduce the labor cost and also increase more output with the TPH, increasing from 5 to 7.5. Continuing on with our innovative solution, the updated work balance table is as follows. We were able to reduce the bottleneck of adding the protein to the sandwich from 90 to 60. The end result is that each task are within the takt time, and thus the rate at which our sandwiches need to be completed will meet the customer needs. Next, our improvement mechanism, our work cell. It has a better flow with tasks 1, 2, 3, and 4 having 2 employees per task, and thus that helps us to ensure that we are able to get that hot, fresh, lean sandwich out to happy customers, thus improving the quality and eliminating the scrap rate. So, by using the Lean Six Sigma tools, the following are the expected savings. The current process, as you can see on the left column, has a TPH of 5, a DPMO of 100,000 with an average of 60 defects per day, labor hours with 12 employees at 10 hours a day for 364 days equates to 43,680. The scrap rate of 10% has the annual failure cost of a little over 120,000. With employees of 12, that equates to 120 hours per day. So the annual wages equates to $655,200. In using the new process that we're able to create using the Lean Six Sigma tools and methodology, we're able to increase the TPH to 7.5, which is a 2.5 increase. We were able to decrease the DPMO down to 20,000, the average of 12 defects per day. The labor hours decreased quite substantially, 21,120 at 8 employees at 10 hours per day, 364 days a year. The scrap rate goal was down to 2%. So from 21,480 sandwiches from the previous process, the new process now reduces the scrap rate down to 4,368 sandwiches with an annual failure cost of $24,024. And with the employees reduced down to 8 to make our lean sandwich shop leaner for our workforce, the annual wages now equate to $436,800. Continuing on with our expected savings, as stated from the previous slide, we increased our TPH by 2.5. We reduced our labor hours by 14,560. We decreased the scrap rate by 8%, thus saving $96,096 annually. We created a lean employee workforce by reducing the employees by 4. And our annual wages, we saved $218,400. So our total lean savings, annual lean savings equated to $314,496. As you can see on the right, we have the sandwich productivity improvement and scrap reduction improvement. This is the chart that we used and the calculations that helped us to get our expected savings. So the conclusion that we came up with is that the lean sandwich shop decreased the process cycle time, which will reduce the top customer complaint of cold sandwiches and ultimately decrease the DPMO. Second, by eliminating waste in task number 3 and task number 5 in the current process, by combining tasks, the lean sandwich shop will greatly reduce the scrap rate and benefit from cost savings. And lastly, the calculations used in analysis were derived from daily averages and did not take into consideration of the hourly customer demands, especially during the peak hours of 12 p.m. Exploration into an hourly analysis will potentially further eliminate waste and optimize workflow processes. Ultimately, the Lean Six Sigma methodology is not used to fire people. It's to eliminate waste and optimize processes, thus creating a lean, solid business. And these are the findings that we were able to provide for the Lean Sandwich Shop. Thank you.